Hey guys, so I'm gonna go over the evens homework for the limits stuff. So yeah, I didn't know that I could turn my camera around. All right, go outside. And so yeah, so I'm gonna turn it back around. And okay, move the arm over here so we can see. All right, so I'm gonna be using the problems off of here, but obviously the evens, we're gonna do numbers 2 through 18, okay? So hopefully you looked at the PDF I put because these ones were hard to see on the original, so I wrote them in, okay? And here we go, on to the evens. So this is page 798, numbers 2 through 18, evens. So hopefully by the evens, we have a better handle of how to do these problems. So I'm starting with number 2, okay? And on number 2, I have h of x equals 2 minus 3x over x. So I can automatically see that if x is a 0, it's going to make the function undefined. So I'm not allowed to plug in a 0 for x, which is going to be hard to find the limit as x approaches 0. So I will have to find the alternate, which I have to do anyway, okay? So yeah, so let's look at these real quick. The limit as x approaches -2, so -2 is about right there. I don't know exactly where that is, so it'll be easier to plug in a -2 into the function and see what happens. Okay, and yeah. All right, so let's just go ahead and do that. Sorry, I'm a little bit tired today. Ugh. I've been getting up early and waking up, or I've been getting up early and going to bed late, so yeah, story of my life. And then there's you guys who stay up late. You guys do your work at like 2 in the morning. I don't know how you guys are doing all that, but you do.
Yeah, how am I doing that?
You're not, Lucas. You're not allowed to stay up late. But anyways, okay, so before we go ahead and do the limits, it's easier just to plug it into the simplified version. So I'm going to go ahead and simplify this. So I notice the numerator has a common factor of x. So I'm going to factor that out, which is perfect because then it will cancel out with that x in the denominator, which is what we want so that we can plug in numbers that we know would be undefined. So I can already take care of that. Well, when I divide out an x, I'm going to have an x minus 3 left inside. Okay, so h of x equals x minus 3 is the alternate function that I can use. Okay, so I'm going to box that because that's part of the answer. The other part of the answer is finding the limits. So letter A, we are finding the limit as x approaches -2 of x plus 3. Okay, so if I plug in a -2 for x, I'm going to have -2 plus 3, which is a positive 1. I'm sorry, it's not a positive 1. I wrote x minus 3 and then x plus 3. This should be, rewrite. Like I said, did I mention that I'm like really tired today? And I mean, I know it's been normal though. I've been like going to bed late, waking up early, and it's a normal thing. I've been exercising, I've been drinking my coffee, I still have my normal things, but today, oh my gosh, I feel like I got hit by a truck. All right, let's take 2, plug it in again, -2 minus 3, -5, and there we go. I'm like, that's the answer that I have written on my key up above. There we go. All right, so next one, letter B, is the limit as x approaches 0, the one that we wouldn't have been able to do earlier, of h of x. Let's just put x minus 3. Okay, so plugging in a 0, 0 minus 3 is -3. Boom, shakalaka. Now we're rolling. Okay, the next one is the limit as x approaches 3 of x minus 3. So this time we plug in a 3. 3 minus 3 is 0, so the limit is 0. All right, and that's number 2. Number 4 is another graph. This time we have f of x equals x squared minus 1 over x plus 1. And I see we're undefined at a -1, obviously, because -1 plus 1 is 0. It makes the denominator 0. Okay. All right, so let's go ahead and simplify that first, since we're gonna need to do that. So I'm gonna write down f of x equals x squared minus 1 over x plus 1. And the x squared minus 1 should look highly familiar because we can totally factor that out. It's a difference of two perfect squares. Factors down to x plus 1, x minus 1. And hello, we have an x plus 1 in the denominator. So those will cancel nicely, leaving us with an x minus 1. So the alternate function that we can use is f of x equals x minus 1. I'm going to box that because that's part of the answer. The other part are finding the limits that they want us to find. The first one they want us to find is the limit as x approaches 1 of f of x, so of x minus 1. Okay, so we're going to plug in a 1. 1 minus 1 is 0. So our first limit is 0. As x approaches 1, the limit is 0. For b, we're finding the limit as x approaches 2 of x minus 1. So that would be 2 minus 1, which equals 1. And then letter C, we're finding the limit as x approaches negative 1 of x minus 1. So negative 1 minus 1 is negative 2, and that's the limit. Okay, so those ones weren't so bad, were they? Okay, number 6. We have, sorry, I need to move it closer. The limit as x approaches, what is that, a 9? Yeah, I believe it's a 9. As x approaches 9 of 9 minus x over x squared minus 81. Lucas, that's not only bothering your sister, but it's bothering me too. You need to knock it off. My gosh, one of my biggest pet peeves is crunching in someone's face. I can't stand it. Anyways, so if I were to plug in a 9 for x, 9 squared is 81, and 81 minus 81 is 0. That makes the denominator 0. So I have no choice but to rewrite this, okay? So I noticed the numerator, though, that's bothering me. 9 minus x, that's so out of order. But if I reorder it, it'll be negative x plus 9, and I don't like that either. So let's go ahead and factor out a negative, because you can always do that. When I divide out a negative 1 from the x, I will have a positive x. When I divide out a negative 1 from the positive 9, I will have a negative 9. So if I were to distribute that negative 1 back in, it should go back to the original, okay? And the reason why is in the denominator, I don't know if you noticed, but x squared minus 81 is also a difference of two perfect squares. And that's going to factor down to x plus 9, x minus 9, which allows us to cancel out the pesky x minus 9 that is making the denominator 0. So I'm going to have negative 1 over x plus 9 left. Okay, so now I need to find the limit as x approaches 9. So let's plug in a 9. So negative 1 over 9 plus 9. Well, 9 plus 9 is 18. So negative 1 over 18. Negative 1/18 is the limit. And that was number 6. Okay, number 7. Oh, not number 7. We're doing evens. How many of you do that too? All right, so we're finding the limit as x approaches negative 4 of 2x squared plus 7x minus 4 all over x plus 4. Okay. So for this one, if I were to plug in a negative 4 for x, negative 4 plus 4 would make the denominator 0, so I really do have to find a simplified version of this. Okay, so what do I need to do? I know that the x plus 4 is going to need to cancel. So that means one of the factors should be an x plus 4. Okay, well, what's the other factor then? Well, let's see if we could do that guess and check trick that Mrs. Ardito does. So to get a 2x squared, I need to multiply x by a 2x, because x times 2x is 2x squared. To get a negative 4, I already have a positive 4, so I need to multiply that by a negative 1 to get a negative 4. So let's check it and see if it works. X times 2x is 2x squared. X times negative 1 is a negative x, plus 4 times 2x is a positive 8x. 8x minus 1x is a positive 7x. So that worked. And then 4 times negative 1 is negative 4. So it checks out. So I can cancel out the x plus 4s. That worked nicely. And I get 2x minus 1. All right. So now let's find the limit as x approaches negative 4, which means we're going to plug in a negative 4 for the x. So I will have 2 times negative 4 minus 1, which is negative 8 minus 1, which equals negative 9. Nice. Okay. Lucas, you're pushing my stuff. Number 10. I think I can squeeze 10 down here, so I'm going to try. All right, number 10 is the limit as a approaches negative 4 of a cubed plus 64 all over a plus 4. All right. I put a star next to this one on the answer key that I gave you guys because I wanted you to use the sum of cubes because we can factor this. We learned how to factor these sum and difference of cubes last semester. So hopefully all you have to do is just Google sum of cubes, difference of cubes, and both of them should pop up at the same time, and you'll be able to see examples of how to do those, so to spark that memory. So because it's a cubed plus 64, that means it's the plus minus minus. Let me look at my notes. Because when you don't use these, you tend to lose them. Yeah. Oh, no, plus minus plus. The other one is minus plus plus. This one is plus minus plus. Because it is a sum of cubes, that means you're going to start with the plus. All right, so that means that this is really a to the third power, because it is, and 4 to the third power is 64. So when I factor this, it'll be a plus 4, and then I need to square it, the first term, so a squared, so plus, then minus, a times 4 is 4a, and then plus, plus minus plus, and then 4 squared is 16. Okay? All over a plus 4. Now, if you have trouble remembering the sum of cubes and difference of cubes, since you know that the denominator needs to cancel out, we need the a plus 4 to cancel out, you know that a plus 4 is a factor of the numerator. So you could use long division to find that other factor. You could. Don't have to, though. All right, so these cancel, and you get a squared minus 4a plus 16. Okay, now we can plug in a negative 4. So we'll have negative 4 squared minus 4 times negative 4 plus 16. Negative 4 squared is 16. Negative 4 times negative 4 is positive 16 plus 16. 16 plus 16 plus 16 is 48. So the limit as a approaches negative 4 is 48. That's number 10. Flip it over to the back. Almost done. On to number 12. Okay. And number 12, we need to find the limit as x approaches 2 of x to the 4th minus 2x squared minus 8 all over x to the 4th minus 6x squared plus 8. Okay. Just to check, if I plugged in a 2, 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16, so that would be 16 minus, let's see, 2 squared would be 4. Negative 6 times 4 is negative 24, so that would be 16 minus 24, just typing that in my calculator, plus 8. is 0. So that wouldn't work. So we really do have to simplify this to get something in the denominator to cancel. Obviously, a 2 is making it 0, so that means it's a factor of x minus 2 that we need to get rid of. Okay, so let's see what this factors down to. All right, so it's a trinomial, both top and bottom, but they're both to the 4th power. So we're going to treat it like a quadratic, like we would a quadratic. So we're going to do product sum, and these would be easy trinomials. So we're going to have 2 binomial factors, top and bottom. The thing is, though, is that to get an x to the 4th, we're going to have an x squared times an x squared, because that equals x to the 4th. So we're going to have that top and bottom. Okay. Now the product is -8. The sum is -2x squared. So two numbers that multiply to -8 and add up to -2. Let's see. -4 times 2 is -8. -4 plus 2 is -2. So I need a -4 and a +2 up there. For the bottom one, the product is 8 and the sum is -6. So it's going to be 4 and 2 again, but they've got to add up to a -6, so that means both of these must be negative, and a negative times a negative is how we get that +8. Okay, and we can see what cancels. So first of all, this bad boy cancels. So all we have left now is x squared plus 2 in the numerator and x squared minus 2 in the denominator. Okay. All right, so now we can plug in our number. We can plug in a 2. So we're going to have 2 squared plus 2 over 2 squared minus 2. 2 squared is 4. 4 plus 2 is 6. 2 squared is 4. 4 minus 2 is 2. 6 divided by 2 is 3. Okay, see all this work that you have to show to get to this point? I expect to see that too. All right, number 14. We are going to find the limit as x approaches -3 of x cubed plus 2x squared minus 9x minus 18 all over x cubed plus x squared minus 9x minus 9. Okay, so for this one, it's a cubic, both of these, top and bottom. Obviously, if I plug in a -3, it's going to make the denominator 0, so we need to simplify this, and these cubics have 4 terms. So the easiest way to try this is to see if we could factor by grouping by breaking it in half and factoring each side. If that doesn't work, then we'll have to use synthetic division and the PQs to figure out what the roots are. So let's start with the numerator. And I can factor out an x squared in the first half there. And that leaves me with an x plus 2. After the break, I have a minus sign. And then I can factor out a 9. So because of the minus sign, I'm factoring out a -9. And I will have an x plus 2 left, which means it's factorable and I'm doing it right. So I'll be able to continue on there. So the numerator is going to have a factor of x plus 2, and my leftovers are x squared minus 9. I could continue factoring the x squared minus 9, but I'm going to leave it for now because if it cancels out like that, then I'm saving myself some work, and that's always nice. Okay, and the denominator, if I break it in half and factor each side, I can divide out an x squared, and I'm left with x plus 1. There's a minus after the break, and -9x minus 9 has a 9 in common, and I'm dividing out a -9 because of that minus sign. So I'm going to have x plus 1. All right, they're both the same, so we're doing it right, and it's factorable. X plus 1 is a factor. The leftovers are x squared minus 9 again. Perfect, because these are going to cancel. So I'm going to have left x plus 2 over x plus 1, Now it is super simple, and I can plug in that -3, and I will be able to get the limit. So -3 plus 2 over -3 plus 1. -3 plus 2 is -1. -3 plus 1 is a -2. A negative divided by negative is positive, so this is a positive 1/2. And to make that cleaner, maybe rewrite it. Yeah, that looks better. Okay. All right, that's 14. Number 16, we have 2 left. Number 16, we're finding the limit as x approaches -3 of x cubed minus 4x squared minus 3x plus 18 all over x cubed minus 4x squared plus x plus 6. Okay. The first thing I want to check is like, okay, can I factor this? And if I break it in half and factor each side, I could pull out an x squared and I'll have x minus 4. Over here, I could pull out a 3 and it'll be a -3, but 18 divided by a -3 is a -6. So I'm not going to have an x minus 4. So I'm not going to be able to factor these. Okay, well, if I plug in a -3 for x, is it going to make the denominator 0 in the first place? Well, let's see. If I plug in a -3 for x in the denominator, -3 cubed, -3 times -3 times -3 is a -27. So I'm going to type -27 in my calculator. All right. Minus 4 times a -3 squared. Well, -3 squared is 9. 9 times -4 is a -36, so minus 36. Plus x, so plus a -3, which is basically -3, and then plus 6. That's not going to equal 0, guys. So that means I can go ahead and plug in the -3, and I'll be able to get the limit. So let's go ahead and do that. So we already know that the denominator, when I plugged in a -3 for x here, x to the third would be -27. -4 times -3 squared ended up being -36 minus 3 plus 6. Okay, so we already did the denominator. In the numerator, -3 cubed we know is -27. And -3 squared is 9. 9 times -4 we know is -36. Minus 3 times -3. -3 times -3 is a positive 9. And then plus 18. So we already know that the denominator is -60 because we had already did that in the calculator. The numerator, -27 minus 36 plus 9 plus 18. I would try to do the math in my head, but I already don't trust myself because I'm a little sleepy. -36. Okay, negative divided by negative is positive, and let's reduce that. Let's see. I know that 6 goes into both of these. 36 divided by 6 is 6. 60 divided by 6 is 10. So I have 6 over 10, but this also reduces by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. So ultimately, the limit is 3/5. Okay, that was number 16. And last but not least, number 18, we are finding the limit as z approaches 0 of the square root of 7 minus z minus the square root of 7 all over z. And obviously, if we plug in a 0 for z, it makes the denominator 0, so we have to simplify this. So remember, it's called, or well, Mrs. Ardito calls it reverse rationalizing. So we have to multiply by the conjugate of that radical expression in the numerator. So the conjugate is just the same stuff with a plus sign in the middle. So I'm going to multiply by square root of 7 minus z plus square root of 7. Square root of 7 minus z plus square root of 7. Okay. And we're going to FOIL that out. Okay. So we're going to get square root of 7 minus z times square root of 7 minus z means the 7 minus z gets to come out. Square root of 7 minus z times the square root of 7 is a positive 7 times 7 is 49. Negative z times 7 is a negative 7z. Okay. And then negative square root of 7 times square root of 7 minus z is a negative square root of 49 minus 7z. So these cancel, which the middle term always cancels when you multiply conjugates. And then negative square root of 7 times square root of 7 is a negative 7, because the square root times itself means the number gets to come out. Okay, all over, I have z times the quantity square root of 7 minus z plus square root of 7. Okay, so in the numerator, I notice that I have a 7 and a negative 7. So those are opposites, so they'll cancel. So now I have negative z all over z times square root of 7 minus z plus square root of 7. Okay, well, I need the z to cancel. This is what's making the denominator undefined when we plug in a 0. So those cancel. And all I have left now is a negative 1 in the numerator and the square root of 7 minus z plus the square root of 7. Okay, now I can find the limit. So I have to plug in a 0 for z. So I'm going to use the green because the orange is just so bright. So let's see, 7 minus 0 is just 7. So I have 1 over square root of 7 plus square root of 7. Square root of 7 plus square root of 7 is 2 square roots of 7. And we can never, ever, ever leave a radical in the denominator, so I need to multiply top and bottom by radical 7. 1 times radical 7 is just radical 7. 2 radical 7 times radical 7. Well, when I multiply the radical 7s, the 7 gets to come out, and then it multiplies with the 2. And 2 times 7 is 14. So square root of 7 over 14 is the limit. All right, I hope that helped. And this video stayed under 30 minutes, so I hope you appreciated that part as well. And I hope you have a good one. Whoops, I didn't mean to bump it. And see you in my next video. Have a good one.